Okay, this section 6.3, square root functions and inequalities. Let's get started. If a function contains the square root of a variable, it is called the square root function. The square root function is a type of radical function, so you will hear us use that terminology throughout. So let's take a look at the graph of f of x equals the square root of x. Now keep in mind here, ladies and gentlemen, the square root function is limited in terms of its domain. Domain, of course, your input x values. We are allowed to plug in a certain amount of x values that would give us real output values. For example, if I were to graph and say plug in 0, well, the square root of 0 is 0. We could start at the origin. If I were to plug in 1 for x, the square root of 1 is 1. 1 comma 1 follows. Now this is where it gets a little interesting. If you were to plug in 2, the square root of 2 is irrational. For the purposes of today and this lesson, we're going to try and stick to only perfect squares in our as our radicands. Okay, so what we will do is, instead of choosing 2 as the next input value, we will choose 4, because that's the next on the list. And the square root of 4 is equal to 2. Alright, 1, 2, 3, 4, up 2, that puts us right here. Now for the purposes of 6-3, we're talking about the principal root here, which means you do not have to worry about the plus and minus out front. Alright, and you can keep going with this. In other words, if I were to plug in 9 for x, the square root of 9 is 3, and you can go ahead and plot that over here. So this is what the graph will look like in the square root function. Now let's talk about the domain. The domain, because of the principal root, we're only concerned with the positive values of f of x, which means that if I were to say, for example, if I were to plug in -1 comma, well, what's the square root of -1? It's equal to that imaginary unit. So we're not going to be talking about what happens to the left in terms of its domain, which means we are limited to all positive integers. So our domain would be 0, include it with a bracket, and send it over to positive infinity. Now range values would be the same, 0, comma, infinity, because if you think about the output values, everything is above this red line. Okay? If you think about the input values, everything is to the right-hand side of that red line. So we're talking about our domain range. We will be discussing that further throughout this lesson, so keep that in mind. Next is an example. Number 1, identify the domain and range of f of x equals the square root of x plus 4. Okay, so if we think about this graphically, we know that on the previous slide, this was our square root of x. Well, now I have this x plus 4, which means we have some sort of shift taking place. In other words, if you have your t-chart and you plug in -4, well, -4 plus 4 is equal to 0. And the square root of 0 is 0. So we have been shifted now to the left 4 times. I want you to write this down. We'll see it in a couple slides, but we're going to revisit the AH and K here, ladies and gentlemen, and anything underneath the radical will initiate a horizontal shift. So x plus 4 means shift 4 units to the left. Now, from here, what we can do is we can plug in more x values to get a more an accurate graph. So if I plug in -3 for x, I get -3 plus 4, which is 1, and the square root of 1 is 1. So I can plot this ordered pair. Now the next one down, if I were to plug in -2, I'd plug that in for x here, and I would find that -2 plus 4 is +2. And remember, we're trying to stay away from those irrational, non-perfect squares. So let's not choose -2. The next perfect square up, right? We have 0, we have 1. The next output we want is going to be 2, which can, let's see, how could we get 2 as an output? Well, if we have the square root of 4. So what value of x do I need to plug in that would give me 4? If I subtract 4 both sides here, x equals 0. If I plug in 0 for x, 0 plus 4 is 4. And the square root of 4 is, of course, +2. And so I can go ahead and plot that, and we can go ahead and graph. This is the square root of x plus 4. Notice in the directions it didn't ask us to graph, but here in the next few slides you will have to do this sort of thing anyways, so why not introduce it now? The domain, of course, because we've been shifted to the left 4 times, that is my new starting point. Think of it this way. If you have that vertical line, everything to the right of that vertical line is part of your domain. So -4 to infinity. Now let's draw a horizontal line. Everything is still above that horizontal line, so we're talking about a range value of 0. Okay, here's another example. Identify the domain and range of f of x equals -2 times the absolute, not absolute value, the square root of x minus 4 plus 2. Okay, so let's kind of go back to the previous slide. This, underneath the radical, will represent a shift to the right 4 units. So regardless of what's going on with my output values, because the domain represents the x values, I know that it's going to go from 4 to +infinity. Okay. Now the range, this is where it gets interesting because the range values are concerned with the outputs. Well, the outputs are affected by the a value, which is -2, and the k value, which is +2. And because the a value is negative, we know a little bit of something, or we should, hopefully, that if I've been shifted 4 units to the right, and a k value tells me to go up 2 units, my new starting point, if you will, is here at 4, 2. No coincidence that it's h, k, ladies and gentlemen. That is by design. Now the a value tells me instead of going this direction, what's going to happen with the negative? We're going to reflect over the x-axis. So let's see what that would look like. Let's see what that would look like. If I plug in 4, I'm going to get 2 as my output. Now let's see what happens when I plug in 5. 5 take away 4 is 1. The square root of 1 is 1. And we need to times that by the -2 out in front. Okay, so what I'm doing here, guys, is I'm plugging in numbers for x to make this t-chart. So 5 take away 4 is the square root of 1, which is 1. Okay, and 1 times -2 is -2, plus that 2, which is 0. Alright, so at 5, we're at 0, 2, 3, 4, 5. And we can go ahead and draw our graph. So basically what that means is that my range then, because it's coming from -infinity, it's coming from -infinity, and where's it stopping? It doesn't go above this red line. That has an output value of 2. So that's how you can identify the domain and range of these functions. In the next slides, we'll graph, just like I've been doing here in these first 2 examples. So the h and k values really tell the whole story here. Okay. Your turn. So go ahead and if you want, pause the video, try the domain and range on your own, and then bring it back to life and double check your answers. my h value, my k value, and a. Okay, so we have a shift to the right 6 units. We're going up 5. So that means 6 comma 5 is my starting point. Starting point. And that tells me a few things right off the bat. That tells me my domain doesn't go anywhere to the left of positive 6. And because the a value is negative 1, we're going to open down, coming from negative infinity and stopping at our k value of positive 5. If that didn't make much sense, graph it. You could always identify the domain and range from looking at a graph. Okay, here we are. The infamous slide with the AH and K. So you have your H horizontal translations, your K is your vertical up and down. The orientation and shape, if A is negative, we are flipping over the X. If the absolute value of A is bigger than 1, we are stretching versus compressing if we're in between 0 and 1. Now, keep in mind the horizontal translation. That's when we kind of look at the opposite of what's happening underneath the radicals. So if it says x minus 4, we're shifting to the right 4 units because of the general form being x minus h. So let's kind of tackle through some of these examples. Okay, so how does this help us to graph the function and then state the domain and range? Well, right off the bat, my h value is 2, my k value is 5. 2 comma 5 on your grid is right here. Okay. And from here, ladies and gentlemen, what you could do is create that t-table beginning with 2, ending with 5 there. The next x value that makes sense to plug in, because I'm looking right here, is 3, because 3 take away 2 is 1. And remember, we're trying to stay with those perfect squares. So 3 take away 2 is 1. The square root of 1 is 1, plus 5 more is 6. That's another ordered pair on the graph, 3 comma 6. And I say we find at least 3, okay? We're going to find 3 ordered pairs. I'm not going to plug in 4. Why not? Because 4 take away 2 is 2. The square root of 2 is irrational. Let's prevent using those decimals. So I don't want to plug in 5. 5 take away 2 is 3. Square root of 3 is irrational. Let's plug in 6. 6 take away 2 is 4. The square root of 4 is 2. Plus 5 more is 7. So here we are at 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And now what we can do is connect the dots. And that's our graph. Now the domain is your h value, everything to the right of h. Your range, depending on the direction of the orientation, because we open up, we will start with the k value, and we're going up towards positive infinity because of the direction. We're going up. Alright, let's try another one. Same drill. Now right off the bat, if you just kind of notice your a value is negative, you know it's going to open down. So when you think in terms of range, you're going to be coming from negative infinity, and you're going to stop at your k value. So if we wanted to, right now, we can go ahead and plot our domain and range based off of h and k. So that part doesn't change. That part doesn't change when we talk about domain and range, but now the directions ask us to graph. So if we know that our h comma k, right? Whoops, I don't want to use the highlighter. Let's go back to the pen. There we go. Our h comma k is the starting point. In this case, h is negative 3 and k is negative 1. That puts us right here. So in our t-table, when I plug in negative 3, I get negative 1 as an output. The next value that makes sense would be negative 2. The next x value up from negative 3 is negative 2, plus 3 is 1. Okay, so let's kind of Look at that again. So negative 2 plus 3 is 1, the square root of 1, but now I have an a value out in the front, so be careful of that. 1 times negative 2 is negative 2, minus 1 is negative 3. So when we're at negative 2, we're going down to negative 3. And that should make sense, because if the a value is negative, we should be going down instead. Okay, negative 1 for x, that gives me 2, irrational. 0 plus 3 gives me 3, irrational. The next one that makes sense is 1, because 1 plus 3 is 4, the square root of 4 is 2, times the a value of negative 2, which is negative 4, minus 1, we're at negative 5. And like I said, 3 ordered pairs is plenty. Go ahead and draw your graph. So the next thing we're going to be looking at are inequalities. The only difference between the equations and inequalities are going to be the dotted graphs versus solid, and then we have to shade based off of the symbols. So that's what we're doing here coming up. So here we have an inequality. We're going to attack this inequality exactly how we did the function, but as I explained, we have just a few more things to do. We have the dotted versus solid. We have the shaded now. We got a shade above or below this graph. So let's take a look. Also, there's nothing involved in domain and range here, so we're just graphing. So I'm looking for an x comma y. Now if I were to plug in 6 for x, because h is positive 6, my k value is the output 0, because there's no output over here, or there's no k value, so it's 0. Alright, so it's 6, 0. 1, 2, 3, 4, 5, 6. We're here. Alright, now I just want to point something out. This symbol means less than. Okay? It means less than, which means that if I want to be completely accurate here, I should probably put a an open circle here. So 1, 2, 3, 4, 5, 6. I'm going to go ahead and put an open circle there, because on the actual graph itself, those values are not part of the solution set. Because remember, inequalities, shaded regions, there's an infinite amount of solutions. So the ordered pair 6, 0 is not actually part of the solution set, so that's why we put an open circle there. Okay, the next x value up is 7, take away 6 is 1, the square root of 1 is 1, times negative 2 is negative 2. Alright, again, it should make sense that we're below this other ordered pair because the a value is negative. 10 minus 6 is 4, the square root of 4 is 2, times negative 2 is negative 4. So we're looking at a graph like this, and we're going to connect it with a dotted line. So there's my graph. Okay. Now, because we are shading below the graph, this is the inequality symbol, is less than. Less than means below. Shade below the graph. Greater than means above. So let's shade. Let's see. We're going to shade below. Now here's the deal. We do have to keep in mind the domain of this graph. Okay? Because it doesn't make sense for us to shade anywhere over here. Because if you think about it, the x values, all of these x values, if you were to plug them in here, we would get an imaginary solution. And we're not about that in terms of its graph. So we're going to keep in mind the domain when we shade, because we're going to treat this like a, kind of like a vertical wall here, and you're not going to go over it. Okay? So in my graph, we don't need to worry about any of those values off to the left-hand side of the h value. So you're going to try one on your own now, and we'll call it a day. Okay, give this one a shot, and pull up the solution when you are done. My h value is -1, my k value is -2. So in my t-table, sorry for this, not okay with that, x comma y, here we go, -1, -2, and because of this symbol, it's greater or equal to, I'm going to have a closed circle. -1, -2, closed. This is going to be a solid graph. 0 plus 1 is 1. The square root of 1 is 1. Minus 2 is -1. The next one up is 3 plus 1 is the square root of 4. 2 minus 2 is 0. Oops. 3 comma 0, rather. And we're going to connect it with, let's see, solid line. Something like this. And there you have it. Now the shade. Where do I shade this thing? Well, it's greater than, and greater than means above. So remember, we're shading above, starting from where the domain is. We're not going to go beyond the h value of -1 because that's outside our realm, if you will. So there you go. Try the homework. We'll talk about homework questions on Thursday. Get ready for your quiz. 6-1 to 6-2 is tomorrow. This lecture is not on the quiz tomorrow, but it will be on next week's quiz. So ask questions if you got them. We're here for you guys.